Hello guys, it's PH here, back for another video. We're gonna be doing a bit different video today because it's not Minecraft, it's not animations, it's Terraria wiring video. And today we're gonna discuss just that. So without further ado, let's jump right into it. So, Terraria wiring is one of the most complex things in Terraria that needs management, aside from building structures, obviously. And wiring a circuit is the most useful thing to automate things in Terraria, such as farms, structures like custom doors or custom displays, you name it. But what we will discuss today is actually the starter stuff. So we have a mechanical lens here, we got the perforator here, we got the vision rod here, and the grand design as our main object. Now we go outside of this lovely thing that I made, and we will be starting with the senders. The senders is quite easy to understand because they are the signal triggers. So we have a switch here. You can place the switch on these 4 configurations. So you can place it on the side, you can place it on the floor, you can place it on the wall. But you cannot place it on the ceiling, unfortunately. Then next we have the levers. So they both trigger the same way, but the levers are bigger and you can only place the lever using these 2 configurations. Now we have the timers that activates every time their interval is done. So in 1.4 we have the quarter, we have the half, we got the 1, 3, and 5-second delay timer. Or timer, just timer. Next is player sensor. So whenever a player sprite hits the inside of the area that it covers, represented by these wire bulbs, are like this is going to light up. Next is detonators. Every step is a signal and it's locked for 1 second. Oh, I forgot to show how the day and night sensor works. So day sensor, as it suggests, triggers when the dawn hits. And the night sensor triggers when the dusk hits. We have trap chest here. There's no cooldown in triggering this one as long as fast, as short as fast as you can click. That's how it activates. Next is liquid sensors. So from the left we have the water, the lava, and the honey sensors. We also have a multi-liquid sensor right here. So what it does is when the liquid gets in contact with them, the sensor will trigger a signal. When the liquid leaves the sensor, it will trigger another signal. So something like that. As you can see how it goes. When I flip the switch, it goes through a grate. And when the liquid hits the sensor, it triggers a signal to the side lamps. Now we have pressure plates. So from left to right, we have the gray, the brown, yellow, blue, red, and green pressure plates. So gray, I forgot to turn on my God mode here. Gray pressure plate only activates using the player. NPCs like the boulder cannot activate it. Same with the brown. Yellow is NPC only. Blue is player only. Red is both. So basically anything. Green is anything. Well, with the exception of floating type enemies. Now we have this steel pressure plate that is thicker or more squiddish than anything else, and what it can detect is projectiles. So any projectiles work, even rockets. So from right to left we have lizard pressure plate, the orange, I think this is pink, purple and cyan weighted pressure plate. What they do is actually send signals whenever they change state, which is the step and the unstep state. Well, this is only obtainable, I think, by crafting, but I know they can be also bought from the merchant. Same with this orange pressure plate, which when you step on it, it breaks and sends a signal. So these pressure plates at the top row are all player only. So you cannot make any NPC or projectile hit it. Another sender is this gem slot over here. And last but not the least, with the 1.4 update, you can also trigger a signal through this, a golf cup. It can send a signal whenever a ball enters the cup. Now with the receivers, these blocks are two-state, and most of the things that are two-state on this game are switchable by wire, including doors, gates, gem spark blocks, chimneys, which are three-state by the way, light sources, and well, decors. These things, cannons, party stuff, anything that has a secondary state or an attack state. We have traps, including that explosive over there. Detonator, because they actually have a second state, but unlike switches, it can be locked. So we have a lever here, we can lock and unlock this detonator. When unlocked, you can basically trigger it. When locked, it's locked. So this has been an anomaly, especially on Chaos video tutorial about wiring, where he made this sample, this almost exact sample, but this was kind of an in-depth example because when I step on it, it delays 1 second after I stepped on it, right? The reason why is I stepped on it and it applied a locking mechanism, and since that locking mechanism is applied immediately while the 1 second cooldown is up, it actually makes the detonator open for 1 more second instead of closing immediately and never turning on. That's because in theory, the detonator swaps the sprite of locked and unlocked when it's on its locked state. So you can really trigger the detonator for that remaining 1 second using right click if you spam it, but it doesn't re-unlock the detonator. Like if I just double click it to unlock it, but it doesn't unlock itself once it's locked by this diode. Next receiver is this grate, which as we seen earlier, lets the liquid pass. We have functional statues over here. We have monoliths. Fun fact, the party center is also a monolith. And we have logic gates or logic lamps for this example, where logic gates are the one that sends the signal. And this top, actually let me throw an example here. I don't know why that bomb just flipped right there. It shouldn't have to clip there actually. Okay, now that we have that, conveyors are also a receiver of signal. So when I flip this top switch, the conveyor switches sides. You can also put an actuator on one of the conveyors, and surprisingly what it does is actually actuate the conveyor, so there's a hole in there. Okay, so let's just remove that actuator pretty quick. Oh, receiver. Teleporter is also a receiver. So I will talk about teleporters in a separate video, like advanced teleporter stuff. Now let's go to the logic. So from left to right, we have the AND, the NAND, the NOR, the OR, the XNOR, and the N XOR, and the XOR. We also have a faulty gate at last. So this is pretty easy to explain actually. AND gate requires all lamps to be on. The NAND gate requires all lamps to be not on. Like not all lamps are on, so at least one of the lamps are off. Let it activate it. The NOR gate requires all lamps to be off. OR gates requires at least one to be on. And XOR gate requires any of the lamps to be on except for the total of one lamp. So it requires not one lamp. So it's activated if 0, it's activated if it's 2, but it's not if it's only 1. And last but not the least, XOR, which requires one and only one lamp to be on. It deactivates otherwise. Now for the faulty lamp. So this switch doesn't do anything. But if we turn all of this on, it will switch the gem spark block on and off. Let's turn it off to it randomizes. So what happens here is this faulty lamps becomes a randomizer. So depending on the evaluation of the lamps on and the lamps off, or the lamps on versus the total lamps. So right now we have 3 out of 5 on lamps. That gives us 60% chance of activating the signal. And for that, actually what makes the gate faulty is this very special lamp called the faulty lamp. So you can actually stack these lamps and connect the wire anywhere on the stack, like so, and it can still do its work. And if you question, if you do like I made this huge stack of on lamps and put a faulty lamp here and place this wire here, it's still 60% because it reads the first group right above the faulty gate. Everything else above is ignored, except the fact that the wire is still connected to a faulty gate, which just evaluates the very bottom group of logic gates. Moving on, we have the wire cycle. So this is a topic that is needed to be discussed, I guess, because this uncovers the real cycle. But before that, how do we place a wire? So like earlier, what I did is this is the grand design method. So I just select this place method, which is the wrench, and I choose a wire color and I just place it like so. I mean, I cannot use the smart cursor for this because this is already smart placement. So one of the things that I also have not shown you how it does is the junction box, which, as the description says, separate wire paths, and it's hammerable. So what it does is you can place it on no walls. So even if there's no walls, it's just floating there. And as you can see, the wire is separated or just cut here because it doesn't connect here, but it can connect on the other side when there's another wire there. Be careful to cut wires with junctions because it will cut the whole wire on that whole tile, even if you place the junction right there. You can, as long as there's a junction here, you can do something like this, which connects this end to the upper end to the lower end. But if you expect like something like this, it's already cut inside. So if we show like this, it's already cut in this corner. So what we need is to hammer this like that, and it connects like this. So for example, if we place a red wire here, it's totally fine. If we place a blue wire here, it separates the thing, so that blue wire cannot mix, so it has that slice. Moving on, I need to remove this, not place more. So this is the cutting mode. Now for the wire cycle. So we have A, B, C, and D in a circle. What we have is red on A, blue on B, D on green, yellow on C. And if we flip the lever, we got A, B, D, and C. The reason for that is the wire cycle is evaluated in R, B, G, and Y order. So after the game evaluates the red wire, it evaluates the blue wire, then it evaluates the green wire and evaluates the yellow wire, which makes sense. But in normal application, when you just want to wire something, it doesn't matter anyways. but in advanced circuits, this matters. Next is wire length. So for now, the only confirmed in 1.4 is the wire length for announcement box. So it only affects announcement box for now, but I cannot confirm yet for teleporters. So what wire length does is it affects the evaluation of the whole circuit. So we have shortest red, which is 6 units of wire. The longest one has 7 units of red wire. So shorter and midway is actually 5 units long of blue wire, and the longest blue is 8 units of wire. So for now, the only confirmed thing is the execution of text using announcement boxes are based on wire length. So that's not really a critical issue for circuits, because we have another thing here called delay, like logic delay. So what we have here is a red wire and the yellow wire connected directly to the lever, and the rest is red wire. So it should call, like for example, red wire gets evaluated first, it will call BA, it will call AA, then the rest. What if we change the red wire on the other side with yellow? So what will happen is BA, AA, BB, AB, and AC. So why is that? It's because it's the red wire side, right? What if we change another, we flip this and make the bottom left red, because we made it yellow earlier, and the right side yellow. If we flip this, same result. Why? Because on the like when you evaluate this normally, you will execute red first, which gives instructions that this came first. Then it will trigger the next wire possible, which in this case yellow, because we have no blue or green wires here. And this will execute this left side. So in order, the first executed is the right before the left. So right, left, until the right side has nowhere to go. So the rest of the left side can be triggered without being interrupted by the right side. Next is, well, this separation of signal. So this is actually not a wire cycle thing. It's more like the one-time thing delay. Or actually, this can prove more on the logic delay. So if we connect here, we press the red, it triggers a red announcement box. If we press blue, it triggers both, right? Using diodes, which is these little sections on here. Oh, by the way, this, if you watch Chaos combination lock tutorial, this is the part where the 5 and 6 need to share a single strand of wire, except the 5, which only uses red, and 6 uses the red and blue wire. So we need to separate the blue one. We need to separate the 6 from 5. What has been done is, actually, let me place this end wires here and an off lamp on both of them. So what this does is turns the lamp off when they're on, so it produces that smoke. But if we remove that, it stays on, but it still does the same thing. So what happens is, when I press red, it turns on this red one. If I press on this blue one, it triggers the blue. So what happens is, like, we see that the lamps here did switch, but the state of the logic gate did not, which did not send a signal to the red announcement box. And basically the gate on the other side, the AND gate, switches state, so it always triggers the blue switch or the blue announcement box when the blue switch gets triggered. So that circuit actually proves the delay also comes from this thing. So for example, we added this gate to turn off only this one. It will trigger both. Because of the delay this introduced, it has no balance on this side, so we need to introduce another of this thing or another AND gate for this other gate here to balance it out. Next is advanced circuits that I built. So this is basically the showroom part. So we have the diode here, which is turned off right now. Actually, let me fix that real quick.
Let's remove this. Place an on here. Place a photo lamp. Where is it? And place back the blue wire.
So why I did that? This one has no reset button. So it's a one-time use. This one is a multi-use, which you can see it's not connected to the lamp. That's why it's multi-use. Flip-flop. You can use it anytime, just like the multi-use, but it switches between left and right. Resettable. Just like the one use and the multi-use, or well, the flip-flop diode, you cannot switch it again using this switch. You need to switch it using the other switch. Next is the cycle switch. Creepy, right? What happens here is, when I triggered this red switch, it triggers the red, and it evaluates which wire to trigger, or which logic gate to trigger. So it evaluates this first gate first, and since the diode is on, or well, the lamp on the diode is on, it will trigger this, which will trigger the blue one, triggers the jump spark, triggers the logic lamp, and it's now the time for it to trigger again. So as you can see on the circuit, it was connected on 3 faulty lamps, right? And based on wire length rule, it will trigger all 3 in order. But the logic delay rule actually makes it stable, because it will instruct these 3 to trigger the gate. Then the logic delay rule evaluates these 3 gate if what will trigger. So the first one gets a trigger because it's on. The second one doesn't get trigger because it's off, as well as the third one. So when the wire evaluation starts again after that logic delay, only the first logic gate executes a signal. For this, we have a parity switch, which I do call parity switch because when you switch the yellow one, it's impaired. When you switch the lower one, it's paired. So what happens is, this red wire gets evaluated, sends a signal to this logic gate, as well as it sends a signal to the yellow one, and sends another to the other logic gate. And what it does is both send well, the left side sends a wire signal to the upper logic gates. The right signal sends signal to the left or to the right logic gates or the lower logic gates before it gets evaluated by these two logic gates over here. So what you can see on the gates, it always goes in paired signal when I switch this lower one, which turns both lamps on, and well, that when it turns off. Now we have a delay gate. What does is just, it lives up on its name, delay gate. So if we put a gem spark block right here, or well, right here, and connect this to a green wire, it turns off or on the gem spark with a 1 second delay. What we don't want to happen is to actually combine this. So if we use the red one, which is used for the switch, and the output for this logic gate, it will just instantly turn on the gem spark and never be turned off by the timer. I also have made a 2-state clock, which gives a different delay per let's say different type of delay per like the timer here. Like this is a metronome, but it's 1 on the left side, it's 3 on the right side. It's kind of a weird metronome, right? Now we have a chained timer. So this is a chained delay gate, which is, as you can see, it's chained. And this has no safety mechanism. So I can just turn on and off the first timer to prevent it from progressing. Now what we have here is a chained timer with trigger shield, which shields the first timer using a diode here that turns itself off, gets turned itself back on using one of these timers. So for this setup, I decided to turn the first switch back on when the timer hits the end, but I can actually do something like this and turn this on once it escapes the 1 second delay timer. Now for more advanced stuff, which is, as you can see here, we are teleported back to the place where our intro came in first. So this is a kind of an advanced build. I forgot to switch that back on. So what we'll do is just do that and do that, because this is my personal reset switch for this puzzle. Okay, so what we have here, let's zoom out, is like when you look at the wiring system, it's very complex, right? It showcases multiple engines. So first we have the detonator here. It will lock for 3 seconds, unlocks it after 3 seconds. Same with the other detonator. And when I trigger both of this, while the other is not unlocked, when they are both locked, it will lock themselves permanently and well activates the levers for us. So as you can see, I can press anything right here, right? But what you don't know yet is the system that I made here, which is, well, you see 6 lights light up above. which means it's only limited to 6 keys. But I can reset it to put another set of keys, and well, that's it. And the one that I input surely will teleport us back to the lava chamber. So what we'll do is go to the side. The answer is in the darkness. And as you can see, there's several parts that are unactivated. And well, you can climb on them. Like really. Okay, so I'm just gonna try and climb this. And as you can see, I placed a braille thing there. And what it basically says, it's a number 686732. That's the braille translation. So 686732. Let's pull the green lever and we will be teleported to our destination. I can actually post a tutorial for this. So this is the wiring and this is the keys that, or the pins that I used. So this is actually the prototype one for stepper keys. So it's these two keys right here. So this is the stepper pit, the start gate, and this is the mid gate. So this is the mid gate until the end gate. So the end gate is not a pin gate, it's actually a receiver gate. So it's a validation gate if you receive or you input the right code or the wrong code, which runs this as teleporter selection. So red wire teleports you back to the surface teleporter, and the blue wire teleports you to the lava chamber, basically. And as well, we have also prototyped a bunch of progressive pin gates. So these ones are like, from this one it failed, it failed, it failed, and it failed. Or well, only the first three are failed. This fourth one is working. And we have exit gates as well. So for the progressive one, our exit gate is a pin type, and it resets itself and the others by inputting a wrong key or any key at the end of the sequence. So that's all for today. Actually, this is the last part of the wiring 101. I hope you enjoyed it, and I hope it's informative and you understood most of the parts, I guess. And I hope I do really help you on this one. And next time, actually, also I do stream on Twitch. You can visit me there. I do play with viewers, so if you can catch me there, you can. I will post my schedule on for Twitch on the description below. If you want something like more about wiring, please let me know in the comment. Also, you can press that like button. It's quick and easy and it's free. So guys, that's the end of the video. I hope this one helped you, or I help you with the wiring stuff. I mean, this is a long video, I know, but thanks to YouTube, it has segments now, so you can skip several parts. And yeah, I will be seeing you guys next time.